Okay, guys, so we are going to talk about molar mass and how to calculate that today. So before we start that, there are a couple of things we need to talk about. We've already kind of talked about moles as a unit, but moles as a unit is going to be our SI unit for measuring the amount of a substance. So if I'm talking about H2O, I'm going to talk about moles of H2O. If I'm talking about carbon dioxide, moles of carbon dioxide. So moles is just that standard unit that we are going to use when we're talking about the amount of something moving forward. Molar mass is the atomic number or the atomic mass of an element expressed in grams. So the molar mass is going to be mass in grams of 1 mole. So when we talk about molar mass, we are talking about grams per mole. So our unit for molar mass is always going to be grams per mole, like I have denoted down here. And then particles are going to come into play in our next section, but particles are the represented piece of an element or of a compound. In elements, that piece is the atom. In compounds, that could be a molecule, that could be a lot of different things. So we're going to talk about particles as a thing later, but in general, if I'm asking you for the particles of iron, those would be iron atoms. Helium, those would be helium atoms. Then we have molar mass. And I already said that up here, but again, it is the mass in grams of 1 mole of a substance. So the units are going to be grams per mole. And then we're going to calculate molar mass using the masses on our periodic table. So we are, silly camera. So here's an example already written out for you. You can do it this way if you understand the algebra and the parentheses. That'll work. What this is saying is there are 2 hydrogens and 1 oxygen in a molecule of H2O. So if you count your atoms, you have hydrogen and oxygen. You have 2 of them. Hydrogen's molar mass is going to be what is represented here on the periodic table. So we zoom in on that. That's 1.008. You need to use all of those decimals when you're doing this. And then oxygen, same thing. We're finding oxygen. Oxygen is 15.99. Sorry about the glare there. So we're looking at our periodic table to find those masses to start with. So that's where I got those 2 numbers. And then I put that into an algebraic equation. There are 2 hydrogens, so I have 2 times the hydrogen plus the oxygen. Solve that out, you get 18.015 grams per mole. Significant figures, try your best to keep them the same. Remember, when we are multiplying, we keep the lowest significant figure. When we're adding or subtracting, we keep the same number of decimals. So because we are adding these 2, they each have 3 decimals. So we're going to keep 3 decimals in our answer. So if we come down here to our first sample, you may have already written this in, but I do want to show you another way of writing this out in case the algebraic way makes your brain hurt. So when we're inventorying aluminum nitrite, I think is NO3. NO3 is nitrate. So aluminum nitrate. We have aluminum, we have nitrogen, and we have oxygen in this compound. There is 1 aluminum atom, and remember, if there's no number, it's 1. So if we're going to represent that here, we would have 1 and 1 there. So we have 1 aluminum atom. We have 3 nitrates. So that 3 is going to multiply by the bottom number. So that's 3 times 1. There are 3 nitrogens. And then there are 3 times 3. There are 9 oxygens. So that's our atomic count. Then we have to come to our periodic table. We have to find our masses. So aluminum is 26.982. So that's going to be times 26.982. Nitrogen is 14.007. And oxygen we already had looked at is 15.999. Notice I am setting this up where I could add them up. I'm keeping my decimals in line. I am keeping my atoms in line, so on and so forth. Now, if these were all ones, which it could be on an example, you could just add it straight here, do what you need to do. In this case, we're going to need to do our math here because there's more than one. So 1 times 26.982 is 26.982. 3 times 14.007. We're just going to do our math here. So that light is really killing me. 3 times 14.007 equals 42,021. And we have 9 times 15.999 is 143,991. And if you write it like this instead of like that, you got it all lined up ready to do your math. So we're going to add those together. We're going to get 4, and you can type this into your calculator. You can do math the old-fashioned way. 9, 10, 6, 7, haha. So do math the old-fashioned way, 212.994. If you want to do that the other way, we want to plug this into our calculator. Plus 42.01 plus 26.982. There we go. See, I can do math. So I like to set it up this way because then it's already in line to do your addition for you. If you like algebra and you want to set it up that way, or you understand how to type that into your calculator with the parentheses, do that yourself. I don't care which way you do it as long as you show me your work so I can know where you messed up if you mess up. So that is example number 1. So our final answer for this one is going to be 212.994 grams per mole of AlNO3. So you have to include the compound in the unit because when we get to our next step, we're going to be eliminating those things. So that is our first practice. Second practice is lead sulfate. Yep, lead sulfate. So, and remember, we need to name these. So if you are like, Miss Gerhart, where did you get that name? You need to go back and study that. So we're going to do our atomic count. So we have lead, we have sulfur, and we have oxygen. Remember, if there is no number, it is an imaginary 1. So we have 1 lead, 1 sulfur, and 4 oxygen in this compound. We're going to then find our atomic masses for those. Lead is over here, and it is 207.2. Sulfur is right here. It is 32.066. And oxygen is 15.999. We do need to do some calculations here, so we're going to have our equals. We're at 207.2. We're going to have 32.066. And we're going to have 15.999 times 4. 63.996. So we're going to add that up. So 63 plus 32 plus 207.2, 303.262. But for significant figures, remember when you're adding, you can only have the least number of decimal places. So we only have one decimal place for lead. So that means we can only go to one decimal place in our answer. So the 6 is going to round that 2. And we're going to get 303.3 grams per mole of lead sulfate as our final answer. So once again, you can do it this way if you understand your parentheses, or I personally think it's easier to keep track of what you're doing and do it in a line like this. So the whole assignment for today is doing molar mass and practicing that. You need to be able to do molar mass without being confused by that for our next section. So make sure you are practicing through writing out your work. So tomorrow, if you need any help, you can let me know and I can see what your brain was thinking. So good luck. Have a good day. Bye.